Hello friends, welcome to this new session in which we are going to study one very important topic from statistics called as sampling. Now there must be some questions that might arise in your mind, such as what is sampling, what are the different types of sampling, what is the need of learning sampling, isn't it? So I welcome you all to this channel, Pankaj Lade. We are today going to see all these concepts in detail, what sampling is, what is the need of sampling, what are the different types of sampling, and of course we will be looking at some of the examples based on sampling. So let's begin with the session. So students, let's take an example to understand what is sampling. For instance, say in your college there are say 1000 students. You have 1000 students in your college and we have conducted one test on say mathematics and statistics. Say the test was for 10 marks. The test was for 10 marks. There is 1000 students in the college. Now this count of 1000 students is called as population. I'm going to call it as population, or it is also called as the universe. Now the quantity in this population or universe can increase. That means instead of taking the example of a college, we can take the example of an entire university, or we can go further and take the example of entire country, or we can even go further and take the example of the entire world in which people are studying one topic, mathematics and statistics, in which we are learning sampling. So population, the value of population can keep on increasing. For a simplicity purpose, I have kept the value as 1000. So there are 1000 students in a college divided into 10 divisions of 100 each. So there are 10 divisions in which there are 100 students in every division. So there are 1000 students. I want to check that what is the average marks that has been scored by the students, average marks that has been scored by the students. Now to do this, there are two different ways. The first way is the census method. The census method. The first way is the census method. That means I will go and ask every single student how much marks they have scored. Now you can understand, to ask 1000 students, it is definitely going to cost us some time. And if the number increases, say it becomes a lakh or 10 lakh or say 100 million, isn't it? So it becomes a huge amount of data to be processed. So it becomes slightly difficult if I take the entire population. So census method is not always feasible. It is time consuming, it is very costly, very expensive, isn't it? And it is also a tedious method to get the data. So one of the method is census. The other method, the most significant method or the most advantageous method, is nothing but the sampling method. It is the sampling method. So what is sampling method? So what I'll do is, I'll go to every class in which there are 100 students and I will select say 10 students at random. I can select 10 students at random. So there can be two different kinds of selection. There can be random selection and there can be deliberate selection. That means I will forcefully select only particular students of my choice. At that time it is called as deliberate selection, whereas the other one is random selection. For instance, I will take 100 chits, I'll take 100 numbers, put it in a box and then select any 10 chits out of that. So that is called random selection. So I will select 10 students at random, isn't it? It's called lottery selection. It can be called as lottery selection. So 10 students I will select at random and I will get the average marks scored by those students, average marks which is scored by those 10 students, and so on. I will take 10 students from every division, so that becomes 100 students out of 1000 students, isn't it? 100 students out of 1000 students. So I have a sample whose size is 100. So now to get the mean, the average of these 100 students can be far more easier compared to 1000 students. So this is what the advantage of sampling is. So sampling will basically save lot of time, and definitely it will save lot of money also. If you take the example of the elections, isn't it? So you must have gone to cast your vote. Now what happens is, after the election, many of the news channels, they come with something called as an exit poll. What is this exit poll? It is nothing but the sampling. So sampling is nothing but what? It is getting data, isn't it? Getting data, but not of the entire population, only of some part from the entire universe or the population, and analyzing that much data and then scaling it up for the entire population. So this is what sampling is, and you have understood what sampling is and what is the need or what is the advantage of doing sampling. Now students, there are two different methods of sampling. There is one called as large sample and the other one is called as small sample. Now large sample is basically whenever the size of the sample, now remember, the size of the sample is denoted by small letter n. N denotes the size of the sample. So whenever the size of the sample is either 30 or it is greater than 30, so I can say greater than or equal to 30. So whenever the size of the sample is greater than or equal to 30, then we call this as a large sample. We will call it as a large sample. And whenever the size of the sample is less than 30, so 30 is not included here, 30 is included in large sample. So whenever the size of the sample is less than 30, at that time it is called as small sample. We will be calling it as small sample. Now what we do is, we will get the statistical data of these samples. We will get the statistical data, the statistical characteristics of this entire data, the large or the small sample, and based on that we will be predicting the statistical characteristics of the entire population. Listen to these words carefully. I will get the statistical characteristics. So when I say statistical characteristics, what do I mean by this? Statistical characteristics are basically nothing but, say, mean of the data, isn't it? Mean of the data. So average marks scored by the students is nothing but what? It is a mean of the data. So mean, there can be something called as a standard deviation, isn't it? You must have heard these words in your lower standards, standard deviation, or we sometimes also call it as a variance, v of x, and so on. There is range, there is quartile deviation, and plenty of statistical characteristics are available. So if I get the statistical characteristics of the sample, it is called as statistics. It is called as statistics. And then if it is scaled up for the entire population, then it is called as a parameter. It is called as a parameter. So we will be doing what here? We will be getting the statistical characteristics of the sample and we will be scaling it to the entire population. So this is where the need of understanding sampling comes. So students, now you have understood what sampling is, what is the need of sampling, and what are the two different types of sampling. Now obviously we have to understand some more concepts in much detail. So let's move ahead with some of more concepts of sampling. So students, now let's begin with the next important concept, and it is called as the central limit theorem. Now remember that central limit theorem is one of the most important theorems of statistical analysis. So make sure that you understand the definition very properly and very thoroughly, because we will be using this definition to solve the questions also. Now for central limit theorem, we have two different definitions or two different forms available. The two forms are given something like this. The first form is called as the Lyapunov's form. It is called as a Lyapunov's form, and the second form is called as the Lindbergh-Levy theorem. These are the two different forms that we want to understand for the central limit theorem. Now let's see what the first form is, what the Lyapunov's definition of central limit theorem is. Students, let us say if I have n number of variates x1, x2, x3 and so on, and they are independent variates. So if x1, x2, x3 and so on are n number of independent variates. Now when I say variates, you understand that variates basically means observations. They are called as observations, or you can also call them as scores, isn't it? So you can say the marks obtained by the students, they are nothing but what? They are observations, or they can be called as scores. So that is called as a variate. What do you mean by the word independent? So we have understood what is the meaning of the word variate. Let's understand what is the meaning of the word independent. For this, we'll take an example of a deck of playing cards. Now you all know what is the basic structure of the deck of playing cards. You have 52 playing cards. Suppose if I ask you that there is a variant, say x1, which says that you want to select an ace card. Now do you know that there are 4 aces in a deck of playing cards, isn't it? 4 aces. I want to select one card, so the probability becomes 4c1 upon 52c1. So that comes 1 upon 13. Let's say there is another variant where I want to select, let us say, face cards, isn't it? They are face cards. So you know that there are 12 face cards, so it is 12c1 upon 52c1, so it becomes 12 upon 52, or I can say 4 3s and 4 13s, so that's 3 upon 13, isn't it? So this time the ace cards, the face cards, these are nothing but what? These are nothing but independent variates. I can take one more example. Let us say if I take an example of selecting those cards which have a number 10 on them, so I can say the number 10, isn't it? So I can say there are again 4 cards, so it is 4c1 upon 52c1, so again it comes out to be 4 upon 52, which is 1 upon 13. So every time you can see that the variates are independent. So that is the meaning of x1, x2, x3 and so on are independent variates. Now if I have, say, x1, x2 and so on up to xn independent variates with the expected mean, so students, these all terminologies you should already know. When I say expected mean, it is denoted by E of xi, isn't it? E of xi. So expected mean E of xi is given as mu I, and the variance of this variance, it is given by V of xi, given to us as sigma I square. So students, if I have x1, x2 and so on up to xn as n number of independent variates with the expected mean as E of xi, which is given by the value mu I, and it has a variance of V of xi, which is sigma I square, then students, there exists a normal variate, Now students, when I say a normal variate, you need to first of all know what a normal variate means. A normal variate is that variate which will obey the normal distribution. Do you know that there are 3 different types of distributions available? There is a binomial distribution, there is a Poisson's distribution, and then there is a normal distribution. Make sure that you know these concepts first, and then you can come and observe these sessions, these lectures. Only then you'll be able to understand. So please go and watch my previous lectures on probability distribution. So over there you will find all these concepts. So as I said, there will be existing a normal variate which is denoted by Sn, and it is given as x1 plus x2 plus dot 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 till xn. So I have a normal variate now Sn, which is given by x1 plus x2 plus dot 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 plus Sn. This normal variate will now have the expected mean given by mu, which is summation of mu I, and it will have the variance which is given by sigma, which is summation of sigma square, which is given by summation of sigma I square. So you got to understand what the statement is actually trying to tell us. It is trying to tell us that there are some individual variates available to us, x1, x2 and so on up to xn. These individual variates are all independent variates and they all have their own expected mean and their own variance. Then there will be existing one normal variate which is given by the sum of all these variates, and that normal variate will have an expected mean given by the sum of the means of all the variates, and the variance will also be given by the sum of the variances of all the variates given to us. So this is what the Lyapunov's form of central limit theorem is. Let's move on to the next theorem, the next form, that is called as the Lindbergh-Levy theorem. Now there is going to be a small difference between the two statements. Over here also we will be having x1, x2 and so on up to xn as n number of independent variates, but along with the independent variates, the variates are also going to be independent variates and they are also going to be identical. They are also going to be identical variates. Now again you need to understand what is the basic difference between identical and independent variates. So independent variates is again the same thing, isn't it? Independent variates exactly the same meaning that we have already seen. What is the meaning of identical variates is what we need to understand. Now students, I'm going to take an example where I'm going to roll a die. Now do you know that if you roll a die, then the outcomes that you'll be getting is 1, 2, 3, 4, 5 and 6. So when you roll a die, at that time the probability of getting any one of the numbers is every time 1 upon 6. The probability never changes, it always remains the same, isn't it? So such kind of variates are called as identical variates. Further, these all variates are also independent variates, isn't it? So if you get 1 on the die, it has nothing to do with getting 2 or 3 or 4 or 5 or 6, isn't it? Every variate is independent of every other variate, but every variate exactly have the same probability, and that probability is 1 upon 6. So when such thing happens, the variates are called as independent and identical variates. So students, we again have x1, x2, x3 and so on independent and identical random variates. So x1, x2, x3 and so on are independent and identical random variates. Again there will be an expected value. So here also e of xi is going to come, but since all the variates have the exact same probability, then the expected value is going to come mu. I'm going to take the expected value as mu instead of taking it as mu I. In the previous case, every time the expected value mu I was different, the variance v of xi, it was different, sigma I square. So here e of xi is given to us as mu and variance will be given to us as v of xi, which is sigma square. So here every variant will be having the exact same expected mean and the exact same variance. So again there will be a normal variate denoted by Sn given by x1 plus x2 and so on plus xn, but this is what the real difference is. Understand the difference. So this normal variate Sn that you have, it will have a mean. It will have a mean given by n into mu. So the mean of the variate, the normal variate Sn is given by n mu, and the variance will be given by n into sigma square. So did you note the difference in the two theorems? Here the variates were only independent variates. So the normal variate that I've took Sn, that had expected mean summation of mu I, and the variance came summation of sigma I square. Whereas when I went to the Lindbergh-Levy theorem, it takes the variates as independent as well as the important word, the identical variates. Isn't it? I've explained you what is the meaning of identical variates. So if you have independent and identical variates, then again you can get a normal variate called as Sn, which is obtained by the sum of all the variates, but this time this particular mean, the mean of the normal variate, is going to be n mu, and the variance is going to be n into sigma square. So students, these are the two different forms of the central limit theorem. Now, to understand or to solve questions on central limit theorem, we do not generally make use of the theorem statements. What we make use of is the corollary of the Lindbergh-Levy theorem. So let's understand what is the corollary of the Lindbergh-Levy theorem. So students, now let's begin with the corollary of the Lindbergh-Levy theorem. The corollary states something like this. If you have x bar as the mean of a sample, x bar is the mean of a sample of size n. Now understand, if you have a sample, that means there is definitely a population. So we have x bar as a mean of a sample of size n, which is drawn from a population. This sample is drawn from a population whose mean is mu, and standard deviation is sigma. Now try and understand this thing very properly. We have a population. The mean of the population is given as mu. The standard deviation of that population is sigma. From this population, we have taken a sample of size n. So the sample has size n, and x bar is the mean of that sample. Then I can say E of x bar, that means the expected value of x bar, will be given by n mu upon n. Now we remember that from the Lindbergh-Levy theorem, the mean of x1 plus x2 plus x3 and so on was given as n mu, isn't it? So here, if I say E of x bar, the expected value, it will be given by n mu upon n, and the standard deviation, or you can say the variance will now be given as 1 upon n square into n times of sigma square. So if you remember, this n mu and n sigma square, this was nothing but the mean and the variance of x1 plus x2 plus x3 up to xn. So here we have x bar, and this x bar is actually given as x1 plus x2 plus x3 plus dot 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 plus xn whole divided by n. So this value is nothing but n mu, the mean, and then the variance was n sigma square. So that is how I've got the values of the mean and the variance for a sample of size n using the Lindbergh-Levy theorem. Now, once you've understood the mean, which is going to come mu, and the variance, which is going to come sigma square upon n, isn't it? So the variance is going to be sigma square upon n, and the mean is simply going to be mu, because n and n will get cancelled. So mean is mu and the variance has come sigma square upon n. Now students, there is another concept called as the standard normal variate. So from here I can conclude that if Z is a standard normal variate. Now you have to know the concept of standard normal variate first. So if Z is a standard normal variate, then I can give Z is equal to, the formula goes like this, x minus m upon sigma, where m is called as the mean and sigma is called as the standard deviation. Now just now we have seen that the mean we have obtained is mu, so x minus mu upon the standard deviation that is obtained is sigma upon root n. Now try and understand, variance was sigma square upon n, and we know that the standard deviation is nothing but the root of the variance. So you take square root of this term, so you get sigma upon root of n. So this is the formula for finding the standard normal variate. So students, whenever we are going to solve a problem on central limit theorem, so whenever a question of central limit theorem comes, every single time we are going to find find a standard normal variate. So that's a standard procedure. We will always get a standard normal variate, and to get the standard normal variate, the formula is going to be z is equal to x minus mu upon sigma upon root n. You understand the terminologies very properly. So x, or I can better say this is x bar. It is the mean of the sample. X bar is the mean of the sample. Mu is the mean of the population. So there should be a clear distinction between the mean of the sample and mean of the population. So x bar was the mean of the sample and mu was the mean of the population, upon sigma upon root of n, where sigma is again the standard deviation of the population, upon root of n, where n is nothing but the sample size. So students, whenever you get a question on central limit theorem, we will always make use of the corollary of the Lindbergh-Levy theorem. So this is what you should be always remembering. So this is where I'm going to end, students, this lecture. This session we are going to end here. In our next session, we are going to understand how this theorem will be applied to solve questions. So thank you so much for watching. You all have a great day ahead.